Hello everyone, this is Auggie from XGuard RC, and I am very excited to introduce a new product that we have. It's called the XGuard IntelliSwitch. The IntelliSwitch is a RC switch that is designed to handle very large currents that are required for today's servos. Today's servos are very high power, they have a lot of torque, and during flight they generate currents that are a current servo with a set of servos, like for instance 3 cyclic servos and their tail servo together have peaks of over 20 amps, about 27, 24. If you measure them, you will find those. So because of that, I was very concerned about what's available now. And of course I didn't want to use a mechanical switch, because all of people that have experience know that mechanical switches will sooner or later fail, and that's why they need to be solid state switches. Now the problem with the current solid state switches that I reviewed before deciding to make one, they are not really hard core in the sense of the amount of currents they can handle. Also the wiring is very, it's a basic single wire servo style, and obviously that is not sufficient for today's applications. So I decided to design a switch that would be able to handle currents that were much higher, so that the device electronics are way within their operating maximums. So for instance, in this case, we have on the IntelliSwitch, we have 2 solid state relays inside. As some of you might know, solid state relays are actually the current most used type of relays in industrial applications, because the reliability of the solid state is much higher than the mechanical, as well as the noise that the mechanical switches do are eliminated with the solid state ones. So if you look at the solid state switches, or better called solid state relays, the inside of the relay contains some components that make the solid state relay into what it is. So if you look at the IntelliSwitch, you will find that there is 2 of those components, the actual solid state relays inside, and each one of those in our switch can handle 120 amps. That is a total of 240 amps that the device can electronically handle. Does not mean that these wires can handle that, because applications within the RC world are going to need less than that in the electronics powering receivers and servers and all that. Obviously on ESCs and things like that, that is not the case. You can have higher currents, but this is not a switch for that. This is a switch for your RC electronics, meaning the flyverless, the receivers, the servos, and everything that is connected to the whole system. So the first thing that I did in this design was, I didn't like having servo wires being the ones that would pick up from the batteries. So we added a 14 gauge wire, and that comes pre-in, so you can install the type of connector that you want. In this case, I added an XT60 connector, and the reason why I use that connector is because of the type of plugs it has. So you can see they are solid plugs, and they are not what they call bird cages, which are very unreliable. So, and this actually works for both the EC3 and the XT60, so they actually are a solution for either one. So if your battery is EC3 or XT60, I recommend that you use one of these to install in your IntelliSwitch. So based on that, now we have a 14 gauge wire. A 14 gauge wire can handle about 35 amps, each. So we can draw 35 amps within the operating range of a AWG 14. And then the output is something very interesting. Another thing that I wanted to have is, as you can see, I got two ports. Let's bring them closer. The two ports are actually what normally is used as master and slave, right? So as you can see here, there is two connectors, two servo connectors that allow you to have two servo wires going into your receiver or flyverless unit or whatever you're using, right? Another thing that is pretty cool about this is that out of these two, the top one, you know, when you look at the connector here, the top one has an actual is listening to the signal. Like for instance, in this case, let's say we have auxiliary 2 and we connect auxiliary 2 to the top. Okay, so auxiliary 2 goes to the top, so let's put this one in the bottom. Okay, this is the bottom one and the top one, right? Okay, and now if I adjust my radio, program my radio so that auxiliary 2 has a pulse, auxiliary 3, I'm sorry, auxiliary 3 is where I have connected to. So auxiliary 3 has a pulse that is used with a switch that attends to a switch. Then this signal is listened to by this switch. It is able to listen to that signal because with the switch it comes a buzzer that, in the case of when it's connected to a radio channel, doubles as a locator buzzer. So in other words, if you have it connected to, let's say, auxiliary 3 and I program the switch to do that, then if you have your heli or your airplane crashes in the bushes and you cannot find it, you simply switch that and 100 dB loud buzzer will sound, and it has two exits for the sound, one on this side because this one has two physical ports, and one inside that has these two slits here. And so if you have this thing inside, let's say this is the wall of an airplane, and you have your IntelliSwitch inside, the slits here let the locator alarm sound come out, and you can listen to it. You can hear it from a very long distance. It's amazing how far you can hear these things. So I'm gonna show you that once I connected the whole thing. I'm gonna use another with a longer wire so I can move them easily. Another cool feature that this new unit has is I wanted to be able to not only use servo, but also in some applications you want to have the ability to use thicker wires, right? Like for instance, in this case, I'm going to use a 14 gauge wire with the same gauge as the one in the input side. So with this type of terminals, you can use a larger gauge wire, and now again you have more current carrying capacity than your standard servo wires, even though they are, two servo wires, two number 20 servo wires can handle 11 amps each, with according to the see, this one is fully tightened. So you put the other one, the negative. As you can see here, here's the plus and the minus sign, so you don't get confused. Plus sign, minus sign, same like here, signal plus and negative, right? So it says XGuard IntelliSwitch. Also, the maximum voltage on the input is listed here, because this is not, like I said, this is not to power 6 cells or 3 cells or 4 cells, or this is to power receivers, and the input signal, the input voltage here has to be maximum the 2-cell 2S Lipo, which is 7.4 nominal, 8.4 when it's fully charged at 4.2 each, so it's 8.4. So this has a maximum input of 9 volts, within safe range. and should not be used for any higher voltages. So the current here, and now based on this, now what limits the amount of current that you can handle with this switch is the wires, actually. So these wires are 32 amps. So this switch now can handle 32 amps because the switch itself can handle 240. And that is a major thing that is important to understand. Why did I go with that such a big capability from the solid state side? Well, because when you do that, then your margin of operation is very, very large. And that is the way we are used to design in America, because of the specs are usually very, very tight. So we have things like that. So this here can handle, like I said, 120 plus 120, and it adds an additional thing which is very important to me, which is redundancy. Redundancy means if one fails, you have another one that will take over, and that is a very important feature of this switch. I wanted to have peace of mind, put a switch that I knew was never going to be the issue in an installation of an aircraft, whether it's a helicopter or because I also fly large gassers, and they use large servos, multiple servos, and they also use a lot of power. So I wanted to have a switch that if you want to go from here to a power board, distribution board of power, you can go with these wires into the switch, come out with the same wires, same type of gauge wires, go into the power board, and this thing can control the power board without any problem whatsoever, the power going into the power board. So that's the first part of this video. So let me go now and connect this whole thing, and I'm going to take it out of that so it's easy for me to handle it. Okay, I'm going to take it out of this wall here, and I'm going to show you also the hole pattern that is done on this one, so you see which one is the kind of hole pattern that you need for these switches. I took the switch off of the plate, and as you can see here, the pattern for the hole is a typical pattern like you see in other helicopters or airplanes. It's a typical, actually smaller than normal, so it will for sure fit in the one that you probably have. The dimensions are I'm going to show it to you in this the screen. As you can see, the dimensions are in millimeters, and they show you what is the size of the hole that you want to make if you want to mount it on a panel like a frame or a side of a fuselage with the push button facing outside. You can also mount the unit by using double-sided tape on this side and on this side. As you can see, there's a slightly difference in height due to the buzzer, but it's less than the typical double-sided tape, so you can use that. And then I think that the output is this way, so even if you have double-sided tape here, the output is going to come out from this end and also from these two slits here. So that works for that. So you can mount it on an aircraft with double-sided tape, or panel mounted with the plate here, with the carbon plate that is doubles as a washer also. And so that's how you mount it. So let's get going with the operation of the switch. Okay. So I'm going to start with 8.2 volts here. All right. So as you can see, it is blinking green and red, and if I don't turn it on, it will default to go back to standby. Okay. Now the standby on this unit, that was a very important thing for me. I did not want to have to remember to unplug it from whatever I have it plugged on, because of pretty much all the switches that are out there discharge the batteries if you forget to unplug it from the power source, from your battery. So one of the most important things also was to be able to leave it connected without having to worry about discharging the battery. Now, physics, the laws of physics say that despite what I want, there's going to be always a little bit of a draw. But in this case, I was able to manage to get it so low that if you leave it connected to a 5,000 milliamp hour pack, at 2S, it will take 92 years to discharge it. So believe me, don't worry about leaving the thing on, because if your pack lasts 92 years, well, you have to tell me how you manage that, because that's pretty much impossible. So 92 years of standby, you get a very large number of hours that when you calculate it's 92 years. So 92 years is what it would take for this device to discharge a battery. So obviously you can leave it on, no problem whatsoever. So the features on this thing. Okay, so I just did a power up, right? And it did this, and then it did a standby musical tone in a very low level, because to tell you that it did the standby mode, went into standby mode without making a connection. If you actually make a connection, then the standby mode musical tone is much louder. Okay, so I'm going to do this again. I'm going to power. See, okay, 8.2. Now I will wait 10 seconds, right? So you can see the LEDs are working. Listen to it. So that was the little musical tone that did that. All right, so let's say I have it on. So if the way this works is pretty cool, because we have a first one is to arm it, and the second one is the actual one that makes it work. So first one is arm, that means armed, I'm sorry, and then another one, and then it's green, meaning it's working, connected. That single beep you heard, the beep, was to tell you what mode it is. So there's 4 modes on this switch. 2 of them are for lipos and 2 of them are for nickel metal hydrate / NiCads. And what the meaning of that is, this device has a warning. It's always measuring the voltage on your packs and making sure that you have enough to go fly. So if you have a green light here, it means it's above, in the case of Lipo, above 6.7. If you have a red one that is blinking, it's warning you that it's getting low. And if you have a fixed red one, means it is too low, you should not fly. And so additional to that, you're going to have a warning sound here, multiple beeps when warning, and a siren when it's too low to fly. That sound is also programmable. You can select whether you want to have it working or not. So in this case here, because we are on Lipo voltage, okay, I'm going to go to, let's say, 6.6. Okay, so let's see. Okay, 6.6 volts. As you can see now, we have a blinking red, and this this one means warning, you're too low, you're below 6.7. Okay, and if we go back to the regular power, then it's already green. Now let's go to, let's say you start your aircraft and it's too low, so let's go to a much lower voltage. Let's see. Okay, now we have 6 volts. That is a solid red, and that is a siren. See, the siren tells you you should not fly. Do not fly this device. If you have a Lipo, it's too low, so it tells you to do that, and it tells you that you should not take off with the device in such a low voltage state. Okay, so I went back to 8.2. all right, And now the question is, how do you turn off? Well, the way you turn it off, if you hold it, and it will give you blinking red and solid green, and meaning it's entering the standby mode. The standby mode. Then once you do that, once it gets into standby mode, it will give you the beep that indicates that it went to that. So look at that. It's blinking, and that is the musical tone for the standby mode. Right now, this device is in standby mode, consuming billionths of an amp. It is paying attention to your controls, your switches, and things like that, in case you do something like, you want to arm it. See, it's armed. Okay. And if I don't do anything, that's it. So it turns off. This is so in case you bump it, you don't want your aircraft with the servos. Maybe you have folded blades, or you have your airplane with something holding the elevators or the ailerons or something. And if we went and directly turn on just simply by pushing once, then you run the risk of burning the servos. So that's why you have to arm it first, and then confirm that you want it on. Same with the off. The off, you have to hold it for that long, because you want to make sure that you really want to turn off. And when that happens, it will give you a confirmation tone telling you it went into standby. So that's the way this thing works. Now, the next step, this is pretty much what it is about the device. It's pretty awesome. I love this switch, and it's the answer to what I wanted. I wanted a very, very reliable, very powerful switch that could handle anything I could throw at it, and not worry about this thing anymore. All right, let me show you how the locator alarm works. First of all, I'm going to use a spectrum, and notice how the auxiliary one on this one is active with this switch. See? So once you have that programmed, you connect that auxiliary one. Okay, I have it connected to the top port there. So we have it here, and what I'm going to do is I'm going to go ahead and turn on the so arm and touch meaning on. Okay, so let me see, what do I have here on the let me put it on the throttle here, and okay, good. So now I have command of the servo, obviously, and I'm going to go ahead and switch this switch on. This switch, and that loud is it's very loud. It's pretty annoying when you're very close. So that is notice that it's facing down. So see that? That's coming mostly from the top, from the switch plate. So on off. That's the way you control the locator alarm, and that's how it works. Okay, so let's go now into programming. Alright, programming the device. So to program the device is very simple. First of all, notice that I have zero power, right? I don't have any voltage. Why? Because programmability is only activated on power up, not from standby. So you don't make a mistake and start this programming this when you're simply standby. So when I start, I'm going to do the arm and immediately push and hold the on and then release it to get the programming mode. The programming mode has a musical tone that tells you that it's in the programming, and then it has beeps: 1 beep, 2 beeps, 3 beeps, 4 beeps, and then 5 beeps with a higher pitch. So those 4 first are Lipo with sound for warnings. Number 2 is Lipo with no sound for warning. Number 3 is NICAD or nicomedia hydrate with sound for the warnings. And 4 is NICAD or nicomedia hydrate without the warnings. Pretty much 1 and 2 are Lipo, 3 and 4 are nicomedia hydrate, and with or without warning sound. The 5, which is, you will hear, it's a 5 tone with higher beeps, is so that if you have very few channels available, right, in your receiver, let's say you don't have auxiliary or something like that, you have main channels, maybe the channel you have available, it's being used for something else, and you don't want that channel to be turning on the locator buzzer. Well, then the number 5 on the programming is whether you pay attention to, in this case, for instance, auxiliary 3, to be triggering the locator buzzer. If you reply to that during the programming with 1 push on the 5, on the number 5 section of the programming, it will not pay attention to that, so your switch will not turn anything on. So like I said before, that's in cases where you have less number of channels than, so you don't have an auxiliary channel that you can use for that. Okay, now the programming. As you can see, I don't have any power right now because programming can only work when you power up the unit, not when you come out of standby, so you don't make a mistake and get into programming when you're coming from standby. So the way you do is you press and press again, when you power up. So you power up, press and press. That first is first mode. 2 means Lipo, no sound. NICAD with sound. NICAD, no sound. And now listen to the different pitch. That means pay attention to the channel or not, and then exit. Okay, that's it. So now it's on. So if I touch the first one, let's say, it will record it as, okay, that's the mode that you want, and then goes straight to the number 5. So let's do that again, okay? I'm going to turn it off, okay? I'm going to do this one more time. So 1, I touch it. That's going to go the 5 tone because I already said I selected 1. And now comes out. Okay, so the way I left it is number 1, which is Lipo with sound, warning sounds. And I didn't press on the 5 tone, meaning I don't want to ignore the switch for the locator alarm. Okay, so that's the default. That's exactly the way it comes from the factory. So mode 1 and with the locator on activated. So that's the way you program it. That's simple. Simply just that. Listen to the tone, select what mode, and then select whether you want to use the switch or not, and you're done. And that's it. That's the way this thing works. You're gonna love it because I tell you, I love mine. I got them on my heli and my gasser, and it's so cool. It's such a nice device. All right, hope you guys liked it. And let me turn it off. Hold it. Okay, and that's it. Now it's in standby mode, and it will take 92 years to discharge the battery. So hope you guys like it, and happy flying. Bye bye.